Okay, so this is lesson 10-3, example number 1. And so this is the example that you see on your paper. And the book has a certain way of doing it, and I'm going to walk you through that process first, but then I'm also going to show you some other ways we can take a look at it. So the first thing that we'll do, since we've been working with algebra tiles, is let's set this up using algebra tiles. And so instead of my pencil here, I'm just going to draw a fence. Okay, and so we have 4x plus 6, and that equals x on this side. Okay, and the goal of this is to get the variables by themselves. And so the way the book is doing it is that they're taking the 4x off of this side and moving it over to the other side. But how do we actually do that? And so what we've been talking about is that in order to actually get something off of one side, we need to bring in the opposite. So here, in this example here, we're bringing in negative 4x. So in other words, we're subtracting 4x, and we have to do that from both sides. So we subtract 4x from both sides, and is illustrated here by the algebra tiles. Okay, and as we've said, the same size but different colors will cancel out. So red and green cancel out, red and green cancel out, red and green cancel out. Okay, and on this side, the same thing. Red and green are going to cancel each other out. And this is what we have left at this point. Okay, and typically what I say is at this point, what we would do is we do the turn and burn, where we turn these, burn them, in other words, just separate them, and then we deal these out like algebra tiles. Or sorry, deal these out like cards. Okay, and so what this is really saying is that this is really saying negative x equals positive 2. So, but that's not quite what we're looking to find. We don't want, in here we have an x, and here we have a positive x, and here we have a positive x. So we don't want to know what a negative x equals. So what I'm going to do is I'm going to bring these back together and take a look at our statement. And our statement says that we have negative 3x, and that equals 6. Okay, so from this point, what we want to say is we need to get rid of what's attached to the variable. X is being multiplied by negative 3. We need to do the opposite to undo it. So the opposite of being multiplied by negative 3 is dividing by negative 3. And we need to do that on both sides. Divide by negative 3. When we do that, negative 3 divided by negative 3 will give us our 1x, and it is positive. And on this side, we have 6 divided by negative 3. Okay, don't forget that when you have a positive and it is being divided by a negative, you get a negative answer. So our answer is going to be negative 2. X equals negative 2. Okay, when you plug that back in, we're going to double check and see if that actually works out. So we said x equals negative 2. Everywhere you see x, we're going to plug that in. So 4 times negative 2 plus 6. Does that equal negative 2? So let's check that. 4 times a negative 2 is going to give us negative 8 plus 6. Does that equal negative 2? And the answer is yes. I mean, you could probably see it as is, just the way it's written here. But if we have 8 negatives and 6 positives, that will indeed give us a negative 2. Okay, so this works. So in this example, x does equal negative 2.